Welcome to the video on combinations and compositions of functions. So before we start, I'm just going to go over some notation that you're going to need to know. And the first is summing two functions. So if I want to sum or add two functions, you'll see the following notation. You'll either be asked to add f of x plus g of x, or you might see this notation, and it means exactly the same thing. You might see parentheses f plus g of x. Okay, these mean exactly the same thing. If you see this notation and it looks a little weird to you, you can always rewrite it. That's actually what I do. So I prefer this notation better because then I can directly substitute. So they mean the exact same thing. Similarly, we have subtracting. If I want to subtract two functions, okay, we're going to see it's either going to be shown as f of x minus g of x, which I prefer that notation, or you'll see f minus g of x. Again, they mean the same thing, and if this notation on the right, you don't like it, I would just rewrite everything to look like the one on the left. That's literally what I do. Okay, so we can multiply two functions. That's going to look like this. F of x times g of x, or you may see f times g of x, okay? And the multiplication is indicated with a closed dot. It'll look like a small dot that's filled in. You probably guessed that you could divide, right? And that's going to be f of x divided by g of x, or you'll see f over g of x, okay? And finally, if you want to compose two functions, and so you might be thinking, well, what do you mean by compose two functions? Well, that means literally taking one function and putting it inside of another, and I'll demonstrate that in a second. You'll see the following notation. You'll either see f of g of x, right? Or you'll see, which this is a notation I do not like, but I have to teach you it, big parentheses, f, open circle, g, x. So this also reads f of g of x. So when I see this notation, again, I rewrite it here. The reason I rewrite it is because I like to think about it as the following. To me, doesn't it look like g of x is the inside function? Right? And doesn't it look like f of x is the outside function? So it's easier for me to see what function goes inside of what when I look at it this way. So these notations are equivalent, but you may want to rewrite it to f of g of x. Okay, so what do I mean? And I'm going to do some examples in a second, but what do I mean by composing two functions? I have a little demonstration that I want to show you. I don't know if you guys have ever seen these like Russian dolls. Can you kind of see what this is? My mother-in-law actually gave me this as a Christmas present one year. And it's kind of hard to tell in the video, but if you basically open it up, you see another doll inside, right? So I always think of this when I think of composition of functions, right? Think of the inside doll as the inside function and the outside doll as the outside function. And what you're gonna do is take the outside function, right? You're gonna leave a space and you're gonna insert the inside function. So you're gonna take the inside function, put it in like this, right? One function goes inside of another. This is an example of a composition of functions. Okay, so let's do the math example of what that'll look like. And I'm gonna go through a couple examples. In the next video, I will work on maybe 2 or 3, and I think you'll start to get the idea.